All right, let's get started. Question number 16. Ready?
Yep.
Okay. 16 is B, 20 is C, 21 is B, 22 is B, 23 is A, 24 is D, 25 is B, 28 is C, 31 is A, 33 is D. So tell me, Zoe, how many got wrong? Valerie?
I got three.
Three wrong?
Yep.
Zoe? I don't know. Hello? Zoe, you're on mute.
Oh, sorry. I also got three wrong.
Okay, let's get started. Any questions you guys have?
This on question 22, I got it right, but what is C?
Okay. Buckminster Fuller is a C60 mod. Okay. Okay. Do you know what's a allotrophis?
Like a different form of the same.
Yes, different form of the same. Buck, it's short form for Buckminster Fullerene is called buckyball. It's in the form of a ball, like a soccer ball, which has 60 carbon atoms in it. That is the basis of nanotechnology. Have you heard about the term nanocarbon tubes or carbon tubes?
Yeah, I studied that this summer.
Okay, that's what it's made up of, carbon 60, buckyball.
Okay. Yeah, I got that one wrong, and I didn't know what that meant.
Well, soot is a compound, right? Soot is basically, you know, like when you burn something, you get soot. It's an unburnt form of carbon. So that's not an allotrope, basically.
Yeah, on 22, I guessed between B and C.
Okay, buckyball is what you have to remember. C60 that has 60 carbon atoms. In one molecule of it, there are 60 carbon atoms. It's like it has a very unique structure where it can. That's why it's nanotechnology will be the future.
Got it.
Okay, next.
And for number 23, I knew it was the equation Fibner, but like I didn't remember the like the constant number. I knew it was Pibner as well, but I wasn't sure like what to do with it. Yeah.
Okay.
By the way, the screen is very fuzzy. Yeah, I can't see you very well.
Okay, I'll call you back.
Okay.
Is it okay now?
Yeah.
Okay. The equation is density is equal to pressure times molecular weight divided by RT. So what is the molecular mass of a gas that has a density 2.05 grams per liter, 26 degrees Celsius and 722 torr. So 722 divided by 760 is the ATM. Molecular weight divided by 0.0821 times 26 is 299 Kelvin. So
It's fuzzy again. Yeah, I can't see you.
all right. I'm getting 52.97, so 53. Is fuzzy right still?
Yeah. Yeah, I can't see it. Can you explain like your process there?
Go ahead and hang up, guys. I don't know what to do. So.
I can see you at the moment.
Is it clear now?
Mm-hmm.
Okay.
Yes.
Did Valeria join? I don't think so. You guys have the best internet though. That's what it is.
Yeah, the internet we have here is not great.
No. I don't think so. I don't see Valeria anyway still. So.
Me neither.
Okay. Next question.
Wait, hold on. I'm doing the math for 23 on my own. 1 second. Make sure I'm doing this right. Also, I'm not like, we had to move to a different spot for better Wi-Fi, so sorry if it's a little loud.
No worries.
Okay, yes, I also got 53.
Okay. Next question.
Let me see here. I got 28 right, but I wasn't like 100% sure on my answer.
Carbon dioxide is a covalent compound. Covalent compounds are made up of are basically molecular solids.
Okay, sounds good.
So it looks like Valerie is not able to get on. Hold on. I'm gonna hang up.
Okay. Okay, there. I don't know why it didn't work there.
Yeah, I think Valerie, your internet is weak though, because I'm continuously checking here. It looks just fine here, to be honest. I have another.
My Wi-Fi's been really bad. I'm not gonna lie. Like my.
Yeah, the app have an app that will tell me what's going on. It seems because I've been teaching online for the last few months now. It's showing pretty good signals. So, okay, go ahead and turn off your webcam though, so it may help us reduce the. Okay. Okay, we did complete the question. The density one.
Number 23.
Yeah. So we. I should not have erased because I thought you were online actually.
Sorry.
That's okay. So 722 divided by 760 molecular weight divided by 0.0821 times 299 Kelvin.
I can't read it, so you could explain it one more time.
Okay, don't worry about it. I'm recording for Liz, so I'll send it to you. Okay.
Okay. Sorry.
We'll keep moving because I have a little limited times, but it's on. I'm recording.
You're gonna send the video.
Yeah, I'll send the video.
I'll just look through there. Yeah. Can we go over number 20?
20. The weight percent of sodium hydroxide dissolved in water is 50%. What is the mole fraction of sodium hydroxide? Okay. So, the weight percent of sodium hydroxide dissolved in water is 50%. So, if I take 100 grams of water, solution, 50 grams is water and 50 grams is sodium hydroxide because it says 50%. What is the mole fraction of sodium hydroxide? So divide by 18 for the moles, divide by 23, 16, 40. Tell me the moles for 50 divided by 18 for water.
got 1.25 moles.
No, 2.78 moles for water.
Oh yeah, 58 H2O, yeah.
Okay, 1.25 moles for this. So what's the mole fraction of sodium hydroxide? 1.25 divided by 1.25 plus 2.78 times 100, or that fraction. So 0.31. Make sense?
Not really. I got lost and I can't read what it says there.
Okay, so I find the moles of water, I find the moles of sodium hydroxide, I take the moles of sodium hydroxide divided by the total moles.
Okay. Sounds good.
Okay, next.
That's all I have for questions. That was it for me.
Okay, let's keep moving then. 36, 37. Put a star mark to 37. 38. 42. 'Yep, that's about it for this test. Yeah, complete that. So you have just 4 questions.
I'm done. Done.
Okay. 36B, 37D, 38C, 42A.
I got all of them right.
Yeah.
Me too.
Okay, that was easy. Okay, let's keep it moving. Remember, what we have not done will be done later on, but right now I'll have to get the basics right, get you exposure to the test. Page 63. Question number 1, 3, 4, 6, put a star mark to 6, 7, 11, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8. Go.
Wait, number 5 too?
1, 3, 4, 6, 7, 11,
Okay.
14,
Yep.
15.
Okay. I have one left.
What's that, Zoe?
I just have one left.
Sure.
I have everything done except one I have a question
on. All right, let's get started. Question number 1C, 3A, 4B, 6C, 7A, 11C, 14B, 15A.
I have a lot of questions.
How many got wrong?
I have a few as well.
Zoe, how many got wrong?
2.
Valerie?
I got 2 too. But some of them I guessed on, so.
Yeah, okay. Well, okay. Let's go, guys. Let's get started.
I have questions over 4 and 6.
4. Okay. The liquid element that is dark colored non-conducting substance is bromine. That's the reason I actually gave this question, because this is the problem with AP Chem. They expect you to know it because they expect the school teacher has taught you guys. Mercury is silver, you know that. Iodine is a solid. Bismuth is a solid because these are metals. Bismuth is a metal. Iodine is a solid. Mercury is a liquid. Bromine is the one liquid which is darker. It's like brown orange color.
Alright, I ruled out mercury right away. So I figured because it was a metal.
Again, this is some common things they expect you to know in AP Chem. And this is the reason why we are doing this test, because it is impossible to cover every material, so you have to get exposed to these things, okay? 6, question number 6, a metal is reacted with HCl to produce hydrogen gas. If 0.0623 grams of metal produces 28.3 ml of hydrogen at STP, the mass of the metal that reacts with 1 mole of hydrochloric acid is... Okay. Alright, so it has to be 1:1 reaction because it says the mass of the metal that reacts with 1 mole of hydrochloric acid. So I'm going to take X plus HCl produces, let's take sodium for example. Sodium chloride plus hydrogen gas. So it's 2 and 2. It says a metal is reacted with HCl to produce hydrogen gas. If 0.6023 grams of metal produces 28.3 of hydrogen, the mass of the metal that reacts with 1 mole of hydrochloric acid. So I'm going to divide this by 2. So it'll be half Na plus HCl produces NaCl plus half H2. I'm thinking about this, okay? It's a good question. So you have 28.3 ml of hydrogen gas. So we can calculate the moles of this because it's at STP. Because 1 mole is 22.4 liters at STP. So we have 0.0283 liters. So how many moles it's going to be? It's going to be 0.0283 divided by 22.4. You get 0.00126 moles of hydrogen gas. So So half produces, so that will be the same thing here. 0.00126 moles of hydrogen. How do I know it's sodium? Let me think about this, guys. What I'm going to do is, let me do this problem on a piece of paper and take a picture and send it, okay?
Okay.
Yeah.
All right.
I want to do this. I don't want to. I want to do this. I think I have an idea. I just want to make sure I take a little bit more time on this. Any other questions?
Yeah, I had a question, number 15.
Yep. Ammonium bromide plus silver nitrate produces ammonium nitrate plus silver bromide. So silver bromide is solid, this is aqueous, this is aqueous, this is aqueous. Because solubility rules, silver bromide is a solid, so it'll be NH4.
Oh, never mind, it says net ionic. Okay, I didn't read the question. Okay, that was stupid.
Yeah.
Okay, got it.
Next.
That's all I...
Yeah.
Okay, let's keep it moving. Question number 16. 17. 20. 21. Put a star mark for 21. 22. Put a star mark to that one. 25. You guys do that. I'm going to do the problem which we were discussing, okay?
Got it.
Yeah, I completed the problem, guys, by the way.
One sec.
Yeah, I'm going to send that one. I don't know the answer. Let me check that one. Yeah, that's has to be right.
I'm done. Me too.
Okay. Did you get my picture?
Yes, I did. Yeah.
Does it make sense?
One sec. I'll look at it. How did you get the 0.00126 from the beginning of HCl?
So if you see the balanced equation, 1 mole hydrogen needs 2 moles of hydrochloric acid. So its ratio is 1:2. So it's 0.00126 is the moles of hydrogen. So I need double the amount of hydrochloric acid.
Okay. I'm not sure I understand what you did there.
Okay. So using the hydrogen gas information, I found the moles of hydrogen. Do you guys agree?
Yeah.
Okay.
Yeah, I got that.
Okay, good. So we already know the mass of the metal. They have already given us 0.0623 grams. Okay. So how many moles of hydrochloric acid was involved? 0.00126 times 2 was involved. The question they're asking is find the mass of the metal that reacts with 1 mole of hydrochloric acid. Right now we have 0.00126 times 2. That's all we have right now.
But why didn't you multiply that with, like, when you got the 49.31, why didn't you
No,
do
I said,
times?
I wrote a comment. It's extra I did. We don't even need that.
Oh, okay. That's where I got confused. Okay.
The reason I did that is if they had asked the molecular weight of the metal, you should have done that one. Or the atomic.
Okay. But why wouldn't you multiply the 2 when you're finding the molecular weight of just... Oh, because it's a 1-to-1 ratio. Okay.
That's why I wrote 1:1.
Yeah.
Zoe, make sense?
Sorta.
Which step are you not sure about?
I don't really have a specific question. I just don't understand.
The whole of it? Okay, did you understand where I got the moles of hydrogen?
Yeah.
Did you get in the top where I got the moles of HCl? 0.00126 times 2.
Yeah.
You sure about that?
Yeah.
Okay, that's all I need. So, if you have 0.0623 grams of the metal mass, then I need 0.00126 times 2 moles of HCl. The question they're asking is how many grams I would need of the metal if I had 1 mole of HCl. So I did this ratio at the bottom.
Okay. Okay, I gotcha.
Okay. All right. Yeah, that was a good question though. I had to think that I was trying to see if do I need to really know a metal, so I just picked the X and just did it. So okay, let's go to 16. Sorry. Let's go to question number 16A, 17C, 20D, 21C, 22D, 25B.
I have a question.
How many
For number 17,
guys
got it
got
right?
How many got right? Wrong, I mean.
I got 1. Me too.
Okay, let's go.
I just had a question on number 17. I divided like all of them. Is there like a faster way to do that?
Well, yeah, you have to divide each one by. Well,
Yeah.
The other way, as the mass are same, you're looking at the lowest molecular weight, atomic weight. The one which has a lower atomic weight will have the largest moles. You don't have to do it for individual. So I'm looking at the lowest atomic weight.
The fraction. Yeah.
The answer should be lithium, by the way.
Yeah.
Yeah. Next.
And then the one that I got wrong was number 22. I didn't know what C was.
Was the answer C?
No, the answer was D. Answer is D. I also got that wrong.
Okay. Okay. I know what you're just saying. I know the A is correct. I know B is correct.
See, I chose A for that one. Yeah, I also did that.
But hold on. I don't like this question. I think A is the answer. It says maybe. Because I know this. So if you want to convert the liter atmospheres to joules, you have to multiply 101.325. You can convert the liter atmospheres to joules. You can do that. Question is the units of the ideal gas law. Oh, ideal gas law, not just gas. Okay, that's correct. A and B are correct. I don't know C. Volt coulomb. Okay, give me 1 second here. Okay. Oops. Let me do this. So liter atmosphere mole Kelvin. I can convert this into joules by 101,325 joules is 1 liter atmosphere. Okay, I can do this. Fine. So I got joules per liter, joules per mole Kelvin. Okay, fine. Now they're asking volt per coulomb. Okay, in electrochemistry there is an equation, E is equal to minus NFE. There's an equation, okay? Stay with me on this. Energy is in joules, okay? This is moles. This is Faraday's constant. Coulombs per mole electron, so mole. And this is voltage. Mole and mole cancels. So joule is nothing but coulomb volts. That's what they used. This is a hard question, guys. Did you understand that? Have you heard? Have you seen this? Have you seen this equation? Have you seen this equation?
No.
Yeah. This is in electrochemistry. This is the last chapter I'm going to teach. I think you should answer it as okay. I want you to write down this. Let me write this. Okay. You can write this. A joule can be converted into coulomb times volts using this equation. That's what you have to write right now. Zoe, have you seen this?
I don't know. I can't quite read what's there. Yeah, can you take a picture of the board and send it to me? It's too fuzzy.
Okay, you should have it. Next question.
Those are all mine.
Huh?
Those are all my questions.
Okay.
I got 21 correct, but can we go over that?
Of the following, the most important experimental information used to deduce the structure of the atom was experimental information used to deduce the structure. My answer is C. What's the answer they have? Hello?
Yeah, they have C. Sorry, I was on mute. That is the answer. I was just wondering if you could explain that.
Trying to see how I should explain this. Where should I even? How should I even start? Okay. Oh, you guys can see the whiteboard, right? You said.
Still fuzzy.
Okay, let me explain this. When an atom is excited, that means you give an external energy to the atom. The electrons from the lower energy level absorb that energy and jump to the higher energy levels where they're unstable, so they immediately fall back. All these electrons fall into first shell, second shell, third shell, and so forth, create what's called the emission line spectrum. This was the fundamentals of Balmer-Rydberg equation? Have you heard about the Balmer-Rydberg equation?
No, I haven't. I haven't either.
Okay, I think I'm gonna have to explain. I have to explain the whole thing. You guys, I need the whiteboard for this. Okay, I'll have to wait on that one.
Okay.
That's why I actually put a star mark 21. Of all the most important experimental information used to deduce the structure of the atom was, I don't think so. It's the most important. It's one of the important experiments, not the most. Okay, we had Rutherford experiment. We had J.J. Thomson. Thomson found the electrons, but for the structure of atom, it was basically the hydrogen line spectrum. I'm going to say these names. See if you have heard this. Okay, Lyman series, Balmer series, Brackett series. Have you heard these names?
No. No.
Okay. Yeah. Then we'll go to. Okay. All right. So one of the things I'm seeing is there are pockets of basics you guys are missing. You guys need to start working on the basics. And I'm really hoping Liz will join us pretty soon, because now what I'm going to do is starting next time is half an hour of problems, half an hour of lecture. Okay.
Okay, sounds good.
Okay.
Yeah, sounds good.
I'm going to be
Next week.
I'm going to be
It's kind of busy for me because I have basketball games like all week.
Okay, if I'm gonna have to keep going, Valeria, we can't wait anymore. I'm gonna record and post it online. Okay.
Okay, that's okay.
Okay. Good night, guys.
Good night.